These are
Well,
a couple of big things that I think will really allow to fundamentally change how we do engineering and really make things much more scalable.
yeah, you're actually correct. I've got a question on this. Welcome to the Internet of Things Equation podcast. I'm your host, Łukasz Malinowski, and let's get started with today's conversation. Today, we are going to talk about digital transformation, design ops, and PLC code generation. Our today's guest is Davy Demeyer. Hello, Davy.
Hello, Lucas. Thanks for inviting me.
Please briefly provide a background, how you started, how your professional journey looked like, and where you are right now.
I started in Belgium when I graduated. So I'm an electromechanical engineer from my studies. When I started my career, I joined a local system integrator in Belgium. And then we were quickly acquired by Actemium. Actemium is a big French company, and currently it's one of the biggest system integrators in the world. So during my first years, I did automation projects. I did them in Belgium, but also some projects in Europe, like in the UK, in Germany, in Netherlands. And then in 2006, I started going to China because at that moment, China started to really boom because of the steel industry that started to take up. And I did a couple of projects there in the steel industry and the chemical industry. And then in 2012, they asked me to move entirely to China, to Shanghai, to build a local team for the automation and software business we had for our multinational customers in China. So I stayed there for more than 10 years. That was really an exciting time. So we see all the multinationals investing in greenfields in China. I had a lot of contact with the global engineering teams. Of course, then set up the collaboration with the local Chinese teams. I recently moved back to Belgium in July, so just at the start of the summer. And I also, at the same time, I set up my own company. So the company name is Axelier, and it's not a system integrator company; it's a product company. And the reason why I made the move is because I see a lot of issues, but also opportunities to improve the way that we do automation.
Exciting story. It proves that you've got hands-on experience in terms of working with actual systems, working with manufacturing. This is something that provides you very good insights. Digital transformation in the industrial Internet of Things, this is a huge topic, but actually not that many people got hands-on experience with that subject. Maybe you could provide us your insights why companies at certain size look into digital transformation in terms of improving their manufacturing capabilities.
I mainly worked with the medium to big size companies. So typically, the customers I worked with, they at least had a couple of plants. And then, of course, if you have to manage multiple plants, people start to think, okay, how can we do the things in the same way? How can we do things in a repeatable way? How can we get insights from the different production lines and the plants? And how can we build value on top of that? So for the end users, they have to go to a more streamlined way of doing their production. And digitization and digital transformation is one of the core building blocks to realize this.
Why digital transformation requires roadmap? That might be obvious question, but I've seen number of digital transformation projects failed, and most of them failed because of the improper roadmaps or lack of roadmaps. How does it look from your perspective?
So what typically happens, companies start with a pilot, and that's good. You always have to start with a small project. And where I see many projects fail, so maybe the pilot doesn't fail, but it's the next step, it's the scaling up that fails. So people put often their best people on the pilot. They maybe do it in the headquarters or in a very important plant that they have. And then maybe it works, and actually they will do everything to make it work. But then when you have to roll this out to other lines and to other plants, that's where it fails. Because in making this pilot, people didn't think what will be now the impact if we have to copy this 2, 4, 10, 20, maybe even 100 times. That's the big issue that I see. And that's also what other companies like McKinsey, they write a lot about this from a high level, but you can also see that they write about the pilot purgatory. So what comes after the pilot? So they have a lot of showcases about example plans that have done good digitization. But now the next step is how do we go to the scalability? So that's the big question.
That's actually a huge question in the industrial Internet of Things. Doing something on small scale, it is very good start, but if you want to obtain the actual outcomes of potential, you need to scale. And scale comes with all sorts of challenges. As you said, if some manufacturer have got number of different sites, then scaling that digital transformation across all of those sites comes with challenges. And what are the main challenges regarding scaling that digital transformation you observed?
Different things. One is the team. So I already mentioned people put their best team on the pilot project, and then you need to roll it out. As long as you stay in the same region or the same country, it can be okay. But if you go to other countries, totally other regions, then it becomes difficult because you have to have the global team that needs to work together with the local team. You also have to work together with your suppliers. So first of all, it's a people issue. A second thing is we don't have enough open interfaces in industry. You often have to really do things by hand. It's in the software industry you can see you can quickly scale because all the software has open interfaces and people really expect that you have open APIs. A third thing is licenses. Licenses in industrial software are often not very transparent. On a pilot project, it doesn't matter. You just pay the license fee. But then what people often fail, and that's one of the big mistakes, is they don't multiply the license fees over the total vision that they have. So imagine somebody has 20 plants and they do the pilot project. The CEO signs off on the project because he really wants to realize this, and then you need to multiply this 20 times, and then people see, okay, with the platform that we chose and this license structure, it will not work. Yeah, so that are three big things. And the fourth thing, and of course that's what I'm working on a bit, we have a lack of foundation to build on. If you look at the automation pyramid, so people are questioning a bit the validity now of the automation pyramid, but you still have the bottom layer, which is the automation. And it's very difficult to build on top of that because there's almost no standardization. There's not a really good way to build this in a scalable way. So that's a fourth thing that a lot of projects are struggling with.
Those are great points, especially regarding the outcomes. Because if company invests into industrial Internet of Things solution, they expect to have some outcomes in terms of business savings, competitive advantage, all of that, right? But if they need to pay more for licenses and maybe for integrators than they get back from that solution, then it doesn't really add up. I think that's one of the reasons why we see so many projects fail in the industry space, because the math does not add up at the very end, unfortunately. You focus on design ops. Could you define that term using simple words?
My focus for now, at least, it's on the process industry. So mainly foods, pharma, chemicals. I got inspired a bit by a lot of DevOps ideas in the software world. And if we look how we could apply this to how we design and build software in process manufacturing, then actually we start from a design. So we are already used as system integrators, and as end users. We first design our software. We use Excel, we use Word, we use Visio, and then we program. And the programmation is for a big part just a translation of the design that you built. So in thinking about how could we apply a lot of DevOps ideas to process manufacturing, we have the advantage we can start from the design. So it actually becomes design ops. We go from design to development, some code generation to deployment.
A very good point. Implementation is often just a translation of proper requirements, both functional and non-functional requirements. And that's why I often say that the clear definition of business goal and requirements, this is the hardest part. The technology is more or less figured out already, right? But we need to be very clear about what we are trying to achieve and what business outcomes we are trying to achieve. Going back to the design ops. How can design ops transform the automation layer into enabler rather than a bottleneck for the digital transformation?
We build a model of the automation. So the model is based on a standard. It's called ISA 88, applied to the automation layer. And when we build this model, in the later step, we generate the codes, but we try to always build the model in the same way. If you have multiple PLCs in one factory, you can build your software in the same way. If you have multiple plants, the platform allows you to put your multiple sites on the same platform and then design all your PLCs or your DCS systems in the same way. It also doesn't matter if it's which PLC is in the plant. So this would work with Siemens, it would work with Rockwell. And this allows you to bring scale to the automation layer as the first step. And secondly, because we know then also perfectly where all the data points are. So we know all the locations of the measurements in the PLCs. We know all the sequencers, the steps, and we know what everything means because we have the design, which is the single source of truth for a big part of the program. And this also allows scalability to the higher level applications like data analytics, like MES, digital twin, connections to the ERP system.
Maybe you could give us a bit more details on how do you cooperate with various stakeholders to create that design, because it's probably not that you just arrive at the factory and share your design and you're done, right? It typically works the other way around, that you need to work with various stakeholders to figure out what they need and how to make it as good as possible design wise. Could you share
Yeah.
some details on that?
So on a project, there's often multiple parties and multiple different kinds of people. So you of course always have the end user who wants to build some system. Then you also have often a system integrator. Often they are quite specialized in the automation. You might also have an engineering company that's involved. And so somehow somebody needs to make the design for the automation software. We start from the PNIDs, and the PNIDs are typically designed by an engineering company. And then the process engineer is supposed to write something down in a certain, often it's a continuous text. And then the automation engineer somehow needs to make a more detailed design where he takes the process definition and he takes the PNIDs and makes this in a structured format so it can be programmed. And so typically it's an automation engineer sitting behind, or before it was an automation engineer sitting behind his computer. He prepares his Excel files, he prepares his Word files, then he sends it out to all the other stakeholders, so to the end user, to the process engineer. Everybody gives their remarks and signs off, and then finally they are ready to do the programming. So what's changed a bit is that people come together and work together on this design. So it would still be maybe one or two persons taking the lead, but you invite other people to collaboratively give comments. Of course, you can do this in Word, but it's not so good. So we move to a more browser-based platform, still the same interface as you would use in Word or Excel. So it's still a lot of spreadsheets, a lot of tables, some flowcharts, but people can see what's happening and work together.
Basically you facilitate that common effort, right, to
Yep.
create this design. You leverage domain knowledge of your engineers, but also propose them tools, if that's correct, right, to basically collaborate with each other in very efficient manner.
Yeah, so we move away from Microsoft Office. So we move away from Excel and Word. We still try to use the same way that we set up the documents before. So in the browser, what you design, it still looks like how you would design it in Word or Excel, but it guides the people. So it holds their hand a little bit. It provides them a little bit a more rigid structure because today often people who are a bit less experienced, or there's not somebody in the team who is very experienced and has some examples. People don't really know how to start with this kind of design. So the platform already helps with this. It also helps to detect mistakes or things that are not possible, and it also helps with giving some suggestions when people do the design.
Some people are not really open to learn new tools, new platforms, new applications. So if you can make them as intuitive as possible. And as you mentioned, if those new tools are kind of similar to what they used to, like the Excel spreadsheet, for instance, then it is easier to convince everyone to give it a try. Once they try it, typically they are happy with the outcome, and basically the whole process takes off. Is it the way that you observe when you work in actual deployments with actual customers?
Yeah, for sure. That's very important. I think it's also a general principle. So that's companies working in the space and that want to move to more digitized engineering. So companies who have more like a classical engineering software and they want to go to something that's more future oriented, they should not totally change their engineering workflows. They should make sure that what they present in the future versions, it's still the same and the similar workflow as people are used to. But underlying, you should think about how do you prepare your engineering software to more easily integrate with other systems and to allow to have the engineering more automated if people desire to do so. So initially, 95% of the engineers will not use the advanced functionality. They just want to have to have their classical engineering workflows. But you need to prepare the engineering software so you can have for the remaining 5% who really want to push the limit that your engineering software is ready for this. And that's also the principle that I always use to design our user interface and how the workflows should be transformed from now concretely from what I do from Excel to and Word to the collaborative platform in the browser.
I think you mentioned something extremely important, which is digital transformation doesn't mean that you need to destroy your current processes, current production line, and start from scratch, right? Basically, that means that you've got some current state, you want to achieve some future state, but you need to design and implement number of steps in between, because otherwise that doesn't make any sense, right?
Yeah, correct, correct. I see a lot of people trying things, but often the step is too big. So it's the same with DevOps. So a lot of people are trying to bring DevOps to the automation world. But what we cannot do today is just say, okay, we give the tools that the software engineers have. We give the automation engineers a command line. They type the DevOps commands. That doesn't work today. You have to look where you want to go, but you need to also define the first step, which should be as close as possible to what people are used to today.
That's a very good point. That the software development is totally different world with totally different mentality than the process automation and managing the actual production rights, right? Like in software, I can just completely remove everything and rebuild it in a few minutes. On shop floor, that doesn't work like that at all. And that brings me to the next topic that I want to cover with you, which is the PLC code generation. So how does the 80/20 rule apply to PLC programming?
PLC code generation is something that many people already tried, and some people actually successfully use it for projects. It's often like individual persons or small teams where there's one or two people who manage it. And if you talk to the people who use this a lot, they typically aim for generating 80% of the code. 100%. Some people try it, but it's almost impossible because for the last 20%, you have to do so much effort to automate your workflow and to handle all the exceptions that you actually spend more time on automating your workflow than actually doing your project. 80% is a good target. Some people just do 20%. They just do the basic layer like the control modules, the valves, the motors. But in process industry, we have a lot of sequential control. In the software world, we would call it single state machines. So these things they can really be automated. You can really generate the code. There's some special tricks to make it very user friendly on the design side, but that should be the target. So 80% is really the target that we should go for, and many people who have set up their own workflows have proven and have confirmed that's the way to go.
Briefly touched about it, but maybe you could dive a bit deeper. So what type of functionalities are included into that 80% that you are comfortable can be generated?
Workflow we set up now is focused on process industry. So again, on process industry, we have ISA 88. And there we have a couple of building blocks that are common language for many people. So we have the control modules. So the control modules are your valves, your motors, your PID controllers, your analog measurements. So this is the easiest thing you can do, and that's what many things do. So you just auto-generate all these basic objects, and you also connect them to the I/O points. Like this, you already have the base layer. Then the second thing you can generate is units. Units don't do so much. They could do a lot of things, but in many projects, they are more like a placeholder. So your control modules all belong to a certain unit. The third thing, and that's a bit optional, is equipment modules. Equipment modules, what are equipment modules? They are a combination of control modules that you control by one command. So imagine you have a long pipe or a flow path and there's multiple valves, and you want to say, I want to open the pipe from this source to this destination. You would just send one command to equipment module, and then the equipment module would help with this. But again, in 80% of the projects, you don't need this. And then the most powerful thing is what we call phases in ISA 88 and in the PLC. This is sequential control. The best way to implement them is as a single state machine. It has some additional things around it. It has some parameters, input output parameters. It has HMI parameters that you put at your HMI or your SCADA. And it also has recipe parameters to connect to the MES system, the batching system, things like this. And it also immediately has the exceptions, because actually half of your engineering work or your design work is handling the exceptions. Half of the time, the first half, you just define the normal procedure. And then the second half of your design time, you have to think, okay, what happens if my destination tank is full? What should I do if somebody manually opens a valve that's on the side? So, and this should all be contained in the phase. And this actually you can design in a structured way, and you can fully auto-generate the code if you follow a certain way of doing this.
I think that's a great point that handling exceptions is even more important than, let's say, normal operations, right? Because normal operation is the easy part. You basically implement everything according to the way it should work. But in reality, things often work not according to the plan. And what you said is very, very true, that handling exception is very, very important. Maybe you could give us some more hints how design ops helps to predict all exceptions and how handle them in very efficient way.
We consider it as part of the design. You design for exceptions. We don't predict exceptions. We think about what could happen, which is what people are ready to do today. So if they make their Excel and their Word design documents, they always have the list with exceptions. Typically, we call them like hold conditions. And we also combine them with start conditions. That's how we do it. It's often a simple table where you make a list of what could happen. If this happens, you jump to another part of your sequencer, of your single state machine, and then you handle this exception. Imagine if the destination tank is full, you will say, okay, now I need to, as soon as possible, stop my pump and close my valves, and then give a message to the operator. We are in hold, and please check what's the issue.
You predict all possible scenarios during the design phase, and that gets converted into the source code.
Yeah,
Which
we try to predict all possible scenarios. So it's the design engineers, it's the automation engineer who makes the initial proposal for the exceptions. It could also be the process engineer, and then you share your ID with the other person. So if it's the automation engineer who prepared, then he will give it to the process engineer, and then he will challenge or maybe give some additional IDs. So it's there again. It's very important to work together, because one person will always forget some exceptions.
Speaking about code generation, AI is currently a very hot topic, and I tested it to generate various source codes, which often work, sometimes doesn't work. But what is crucial, that is typically not deterministic. And what you're talking about is that the code that you generate needs to be deterministic, because otherwise, like that's not the point. Like it's not the way that you handle factories.
Yeah. So look, AI for code generation is very, very powerful, and I also use it a lot. But this is more if you, it's more like a assistant that's sitting next to you and that helps you to code faster. Code generation cannot rely on AI because your code that you generate from the design needs to be 100% deterministic, like you say. If you erase your code, you click the button to generate your code again, and it needs to be 100% the same as when you previously generated. If you use AI, you cannot do this. You click the button again, it will be a little bit different at least. And so if you look at manufacturing, you cannot accept that it behaves like this. And for sure not if you go to the really critical industries like pharmaceuticals, you will have to have 100% deterministic code generation. And I also see when I post, you probably see that I already post some examples on LinkedIn. And then many people say, "Oh yes, this is AI code generation. This doesn't work," and they jump too far. They don't realize there's a more practical step of code generation based on design that's always deterministic. On the other hand, you also see that the vendors are now trying to build the LLMs inside their engineering environments. So Siemens is doing it. I think Beckhoff is doing it. Rockwell has announced something. But that's just this co-pilot thing. You can do this to help you engineer faster, but this is not what will finally generate big parts of the code fully automatically. I don't see this in the immediate future. So the deterministic code generation is what we can do today.
I agree with you. This is also the way I look at it, because whenever I ask AI agent to generate a source code for me, I always need to validate that manually, like go basically line by line by line before I deploy it anywhere close to the production. And in your case, when you've got the design and deterministic way to generate the source code, then you don't have to look at the source code at all, right? It's almost like the compiled binary that we've got out of C compiler in a way.
Yes and no. So as people use this, as people get comfortable with it, they will know they can 100% rely on the generated code. There is one big difference with compiled codes though. So if you look at generated code, it looks very, very readable. So it would still look like it's programmed by an automation engineer, except it's just much more structured. You would say it. You would see it's always really, really very well documented because we also generate the documentation in the code. You can open up the generated code. You can still go online, do some tests. So that's very different from the compiled code. So we don't want to have a compiled code that's very tight. We still want to have the code very readable by the automation engineers. And this is not new. So in software engineering, there's actually also a lot of teams who would generate big parts of the code in some conditions. And then it's also the same principle. So the generated code often is also very readable if in the classical software engineering, people use it like this. It's different than the compilation principle.
Well, yeah, you're actually correct. I've got a question on this. Is there a way to generate the code from the design, then you review the source code, make some changes, and you want to apply those changes from the code level back to the design level, or there is no such possibility to basically merge your code changes and show them on the design layer?
No, so for this 80% of the code that's generated, the design becomes the single source of truth. And so if you want to change the code, you should change the design. Now, something that's very, very, very important is that actually changing this design and then generating the codes actually becomes almost faster than changing the code by hand. Changes take maybe 2 seconds. From you update your design, you click a button, and you import the code in. So we in our first test we use TIA. So the import everything together, it's 2 seconds. So people are really surprised when I show the demonstrations. They say nothing happened, and I say yeah, but it's already finished because it goes so fast. And this is really important because if this is not super super fast and if it's not super user friendly, People will want to always change the code and then later update the design, and then everything will break. So then this workflow doesn't work.
That is so true that you need to make it as effortless as possible. So people will start from design, not the other way around. Because, as you said, if we create that disconnect between design and the actual implementation, then everything falls apart and you do not have that visibility anyway, right? You basically, it looks like your design is not worth anything. So that brings me to the next question. You mentioned that 20% of code is probably better to implement by hand. So how do you present that 20% of functionality on the design layer?
Uh, well, for now we don't implement it in our platform. Also yeah, what people typically do when they design an ISA 88, they can put a lot of things in a structure, even if they use Excel and Word. And then often you have always these special things. Then, so what people typically do, they make a separate chapter and they list all these special things. So it could be some special connection to a machine. It could be some special function blocks or some complex control principles that they need to implement. So for now, the recommendation is just to write it somewhere in a tool. You still use Word or Excel or Visio, where you can, the best way to describe it, maybe add some pictures of how it should be programmed. So for now, that's the recommendation.
Is it possible to generate system independent code, or do you have to generate the source code for every target platform independently?
The design ops ID is platform independent. That's also how we implemented it. So the design part doesn't care about which platform you use. It doesn't care if you use Siemens or Rockwell or Schneider or whatever. But then how do we do the code generation? We use templates and template packages. This is existing ID. This comes from the software world. So you just generate text files that contain how you want the code to look like, and then you add some markup. Some people call it handlebars, and then like this you let it run over your design and you generate the code. Now these template packages, they are system dependent because you have to write them according how the code should look like for the specific system. You exchange the template package and you generate the code again. And it is so the templates packages are connected to the PLCs. So even what you could do, and actually people will avoid this, but what you could even do in extremis is you could have different brands of PLCs in the same plant, in the same system. So you could like have a Siemens or a Rockwell next to each other. You could use one common design where you have the different control modules and the units and the phases divided over these two PLCs. But both PLCs have a different template package. You generate all the code. So part gets generated to the Rockwell standard, part gets generated to the Siemens standard, and it all works seamlessly together.
Is there a way for a customer to update those templates, or maybe to create their own templates, or they just need to focus on design part and templates are kind of static to generate the code for a specific platform?
No, customers have full access to the templates. They can do all the changes they want. They could choose to start from a standard that they already have and convert it to a template package, or they can choose to start from a template package which we will propose, which has already been tested, and then maybe make some changes from there. There's also possibility for bigger companies to put the template packages that they prefer at a central location in the platform, and then they can tell the local teams, look, you should really try to start from these template packages. And then even the bigger vision that we have is connect the template packages with Git systems, the GitLab server, or with even GitHub. Often these will be still private Git environments, but the vision is also that some of the template packages will be just published under open source license. So there's at least one company who has already published a list of control modules. So it's a system integrator in the US called DMC. So they already published a set of control modules for the valves, the motors, the analog measurements, the PID controllers. But it's still on a website where you have to download it, you have to manually import it, in the engineering environment. So what will probably happen is that in the future, when people release open source code for the PLC, they will publish directly on GitHub and then link it to template packages and then synchronize like this. So what will also be enabled by this, it will be much faster to set up a new project. Now people really have to install the engineering environment, they have to find for the right standard, they have to talk to a lot of people. So it often takes quite some time before you set up a new project from scratch, especially if it's a new system or a new version. And so the vision is also a bit that we go to the idea of scaffolding, which also comes from the software world, where if somebody says, "Look, I have this kind of system, and I just want to quickly set up like a dummy project," so you quickly select a template package, you set up your engineering environment, you click the button, and you quickly have like an empty project. And from there, you can build the engineering, and you are started in less than 1 hour. So that's a big bit the bigger vision.
It looks like the software development and best practices that we created for software development are very strongly influencing what's happening in the automation space and on the shop floor. So,
Yeah.
what's the upcoming innovation in that area that you are looking for? Would that be introducing the AI that you can actually trust, or maybe there is some other breakthroughs that you are looking for in the way of automation and code generation?
You mean the innovation in the field that's happening?
Yeah, in
So
the field.
yeah, so in automation, there's quite some interesting things happening, and they should. It's high time that they happen. The first thing that's happening is there's a decoupling coming of the hardware and runtimes. So when you have your engineering environment, you always have to use the hardware from the same vendor. So we are gonna move away from this in discrete industry. There is already a start of this, so you already have independent runtimes. But in the process automation world, also for the DCS systems, the controllers, the DCS controllers will also become independent from the runtimes and from the DCS system running on top of it. So there's an effort that's called open process automation. So they are already running the first actual projects. For example, ExxonMobil is doing the first actual project as we speak. And in the coming months or next year, I guess, the first hardware that is fully certified. So really the future of the controllers. So they call them DCNs. They will be released on the market, and everybody can build on top of them, and they can put different runtimes on top of it. And not only the automation runtimes, but these controllers are so powerful that you can also put other applications on top of it. You put them in a container, in a Docker container, and you put them next to your automation runtime. So that's the first thing I see. That's the decoupling of the hardware and the runtimes. Second thing that's happening is an effort to go to a common automation runtime, because now also every vendor has a different runtime, which means you have to do all your engineering and your coding each time in a little bit a different way. So every vendor has this interpretation. So there is one organization that is doing an initial effort. That's universal automation. People who follow me will see that I'm not 100% convinced by the approach, because they take a different kind of runtime. So they move to a different kind of programming standards than what we are used to. And then jumping back to what I said at the start, we should try to stay as close as possible to existing workflows and to the existing way of doing things. But at least to move to a common runtime, that's also something that I think will change a lot. A third one that's very important is for the coding environments to open up the code files. So many people are not aware, but if you use the older IDEs, if you code, then all your code goes inside the database in the IDE, and you cannot access the code. You don't have the text files. And this is the reason why we cannot share code on a Git server. We cannot share automation code on a Git server. it's also quite difficult for many systems to actually generate code because they have all this code inside a database and this is fully closed. So we see some companies doing really great things. So for sure, Siemens is releasing AX, which is now based on Visual Studio Code. So all the underlying code is just plain text files. Also, the configuration files are all JSON files. Other companies have similar plans. Codesys wants to release Go. And Beckhoff, just a couple of weeks ago, they announced that they will release PLC++, which will have a similar way of doing the engineering. So these are
Well,
a couple of big things that I think will really allow to fundamentally change how we do engineering and really make things much more scalable.
I believe so. And what you said is so important that we kind of decouple the software, the logic part from the hardware, right? Because that gives so much potential. And we've seen that all over the place in the software space, in the cloud space. And now the same mentality, the same capabilities we can observe in the manufacturing space and the automation space. So I think that's going to be a huge one. If there is some factory owner that thinks that what we discussed sounds interesting and they would like to start, let's say that they've got totally legacy systems without any of the modern topics that we covered today. How can they start just to see and test themselves the potential before they decide to commit a significant number of time and money into the whole transformation project?
How they should get started. In the last question, we talk a bit about the bigger picture. So for anything that's design ops related and code generation, if you're in process manufacturing, of course, talk to me. For the other things, like the future of automation systems, one of the things, so if people, when they look at new automation systems, they will start to talk to the vendors. So one of the things that I recommend to do is at least compare the more classical systems already with the future systems. You don't immediately have to select them, but at least already make the comparison and think about it. If you don't select them today, at least what is the implication if you select a certain architecture towards the future, because we will move to these more open architectures. So that's the biggest recommendation. um, Talk to people who understand these things. So for open process automation, these people are easy to find. In general, for there's also a growing group of developers, software automation engineers, who try to bring more these open systems and this software way of thinking together. There is a Slack actually that's open, that's called SASI. So it's the Society of Automation and Software Engineers, and there's a lot of really really technical discussion about of how this happens. So if you want to discuss with the people who know how this works, and you want to get in touch with people who do these crazy things, that's the place to go.
Speaking about asking for advice and discussion, what's the best way for people to contact you, to follow what you're doing, or maybe to ask for your advice?
LinkedIn, that's the best way. So you can follow me on LinkedIn. You can connect to me, send me a message. That's the best way.
Perfect. Thank you so much for taking the time to meet with us today.
Okay, thanks for inviting me.
Thank you for listening. Go to the thingrx.com to find more materials about the Internet of Things domain. I'm your host, Łukasz Malinowski.